In the last section, we created a very simple circuit that turned on an LED. In this section, we're going to continue with that circuit and attach it to the Arduino in a way that the Arduino can control the LED and turn it on and off. And while that sounds pretty simple, there's actually several steps to this, including we're going to have to adjust our circuit just a little bit, and then we'll also have to write some code. And so this is kind of exciting for me because finally it's all coming together in one place and it's all going to work together. Let's get started. For this section, you're going to need everything from part 3. And that means hopefully you didn't disassemble your circuit from part 3. If you did, you can go back to part 3 and look it up and see what that circuit looks like and rebuild it. It should only take you a minute or two. But the starting point for this section is the circuit from the last section, where we had an LED with a resistor tied into the 5-volt and ground on the Arduino. First of all, we're going to adjust that circuit, and then after we adjust the circuit, we will go ahead and write the code for the Arduino so that it will work. As far as adjusting the circuit, let's plan on using pin 7 to control the LED. Basically, to accomplish this, we just need to move one wire. So here's our circuit, and the wire we need to move is the positive wire that's going from 5 volt to the positive leg of our LED, and I'm going to grab the end of it, take it out of the 5 volt pin, and move it to the digital pin number 7. On your Arduino, you have a number of pins that are called digital pins. They're all together here on one side of the board, and they're numbered 0 through 13. We're going to use pin number 7, and that's all we need to do to change our circuit. So if your circuit was working from part 3, all you're doing is moving that red wire from 5 volt to pin 7. Unfortunately, if your Arduino board is plugged in now, the LED is not going to light up because there's nothing telling pin 7, hey, you should send 5 volts out on that line. The next part of this task is going to be that we need to actually program the Arduino so that it will control the pin. And that raises a couple of questions. The first one is, what is a program? And a computer program is really just a set of steps that we're asking the computer to do in order. And I like to think of it as a process. In real life, we have processes to do things to make sure that they happen consistently. So for example, if you take a check to the bank or if you take cash to the bank and you want to deposit it, the bank has a process or a series of steps that they will take to make sure that your deposit is processed correctly. And you really want them to have a process, because if they don't, some of the cash that you deposited might get diverted into somebody's pocket. So a process is just a series of steps that we take to consistently get the same result every time. And then an algorithm is just basically a process that you can use to solve a given problem. So we can take a problem and we can say, how do I solve this problem? And you can come up with a series of steps that you could use to solve that problem. An example of that would be calculating miles per gallon on your car. The algorithm for that would be to fill up your gas tank and record the mileage, drive for a while, fill up your gas tank, record the mileage, subtract the difference to get the number of miles traveled, and then divide that by the number of gallons that it took to fill up your gas tank again, and that would give you miles per gallon. And that process or series of steps would work every time, so we can call that an algorithm to solve miles per gallon. A computer program simply converts an algorithm into computer steps or commands that the computer can understand. What we want to do in this case is lay out our algorithm ahead of time, and in remembering that what we're trying to do is turn the LED on and off and on and off and on and off. The algorithm itself should be pretty straightforward, and it is. A lot of computer programmers will create their algorithm in something called pseudocode, which is basically taking each step that they want to accomplish and writing it down in natural language. Another approach is a flowchart, which is a little bit more formal than pseudocode, but accomplishes kind of the same thing. Let me show you both of them so you can see what we're talking about. So here is our process, or our algorithm for turning the LED on and off. And it's going to start with, we need to tell the computer, hey, use this particular pin, and we're using pin 7. So, hey, computer, use pin 7 for the LED. And then over and over, we want to turn on the LED, wait half a second, turn off the LED, wait half a second. And these waits, or wait half a seconds, are really important because if they weren't there, the computer's super fast and the LED would just be flickering on and off so fast. I don't know if you would think it was off or think it was really dim and on, but by waiting after each change in the state of the LED, you'll be able to see it on for half a second, and then you'll be able to see it off for half a second. You can see that in this case, I'm not using computer jargon or computer language. I'm just saying in natural language, this is what I want to accomplish in this step. So it's basically a checklist of these are the things we have to do to solve the problem. Here's a flowchart compared to the pseudocode, so you can see the difference. The flowchart, we have our steps, and then we put the steps in boxes. And if we had a decision to make, we would have a diamond. So the result is it's just a little bit more formal, but it's pretty much the same thing. For the rest of this video, I'm going to focus on the pseudocode, and we will use that to finish the programming project. When we're coding the Arduino, there are two parts to every program. The Arduino is a special case, and the way it's set up is that it can only run one program at a time. When you turn on the Arduino, it's going to run the setup section of your program, and the setup section will only happen once. When it first comes on, it runs setup, and your setup section will make sure everything is set up so that the program can function. When it's done with setup, it'll move on to the loop section. And in the loop section, it will do whatever you tell it to, and then it'll do it again. And then it'll do it again. So the loop section just keeps repeating until the power goes out. In our case, when you look at the processor algorithm, you can see that part of this is definitely geared towards setup. So this section right here says set up the pin for use. That's going to happen one time at the beginning of the program and then never again. So that would go into our setup section, and then the rest of this is going to happen over and over and over. Turn on the LED, wait, turn off the LED, wait, do it again, turn on the LED. So that would go into our loop section, and that means that it's going to look about like this when our program is done. So here we have set up the pin, setup section, do over and over, and this is all in our loop section. The loop section itself will handle the do over and over part for us. When we're writing Arduino C, you'll know that most commands have a keyword followed by a set of parentheses. And I have an example of the command delay right here, so we can work with that and you can see it as we're going. The values in the parentheses then give more information for the command so the computer knows what to do. If I tell the computer delay, the computer is like, I don't know how long do you want me to delay? Inside the parentheses, we're going to tell it how long do we want to delay. And it's expecting a number in milliseconds. And milliseconds, there's 1,000 milliseconds in every second. If we say delay 500, which is what I've written here, it would delay for half a second. If we said delay 1,000, then that would be 1 second. The values that we give it inside the parentheses are called parameters. And it's possible to have a command that requires more than one parameter. In fact, it's pretty common. If there's more than one parameter, they'll be separated by commas, and you have to give it the parameters always in the same order. Here's another command that we're going to use. It's called pin mode, and pin mode expects to know what pin are you referring to and what mode do you want it to be in. So in this case, this command pin mode is going to set pin 7 to mode output, meaning that we will control whether the pin is high, 5 volts, or low, 0 volts. If we did an input, then we would be able to look at the pin and say, is the pin high? Is there 5 volts on the pin, or is there not 5 volts on the pin? So here are the 3 commands that we need for this program. We have the delay command, which we've already talked about, but basically you just say delay, and then how long you want to delay it, and then pin mode, which we've referred to, and pin mode has 2 parameters. The first one is what pin are we working with, The second one is what mode do we want to set that pin to, and your choices are output or input. And then we have digital write, and the digital write command tells us to change the state of one of our pins. Your options are you can make the pin high, meaning 5 volts is going out, or you can make the pin low, meaning no volts are going out. When you look at these commands, it's important to note that the case matters. Where I have a lowercase letter, it has to use that same lowercase letter or the computer won't understand it. Typically for commands, they all start with lowercase, but if there's more than one word in the command, the second word will be capitalized. So here we have pin mode. Pin, the P for pin is lowercase, the M for mode is capitalized, and you would have to write it that way for the computer to understand it. Once we have a language that we can use, and once we have our processor algorithm, we should be able to take the two and put them together. And you'll notice that in this case, my algorithm is pretty much one for one with commands, though sometimes I've written pseudocode and it'll say to do something, and then when I get to doing that, there's not one command to do it. It might be a series of 5 or 10 or even 100 commands. So we're ready to go ahead and write some code. I'm going to open the Arduino IDE, and at the top I'll say File, New, and you should get something that looks just like what I have on the screen. And we're ready to start writing code. Notice that we have 2 sections to our code. The first section is my setup section. The second section is this loop section, and there are a couple of things that are going on here that have to be explained. First of all, this first line says this is the beginning of the setup section. And for now we can ignore the word void. It actually means something, but it doesn't matter at this point. But you do have to include it. We can't delete the word void. What this is saying is this is the beginning of the setup section, and then this open brace says this is actually where the code starts, and it matches up with this close brace, and the braces are like bookends for your computer code or your computer commands that make up the setup section. Any lines that start with // like this are comments to the human and are ignored by the computer. So I can actually delete that, and to keep this as streamlined and as simple as possible, I'm going to go ahead and do that. So I'm going to delete that, and we're going to put our one command in for the setup section, which is pin mode. And then inside the parentheses, we're going to tell it what pin, and we set it up to go to pin 7, and then a comma to separate our parameters, and then we're going to use the word output. All commands in Arduino C end with a semicolon. So semicolon in this case is kind of like end of sentence. And we don't use a period here because if you're using decimal numbers as 5.7, that would confuse the compiler and it would say, oh, end of sentence at the 5, and it would ignore the 0.7. Computer scientists have defaulted to the semicolon instead. Our setup section is now done. We have void setup, we have an open brace and a closed brace that says this is the setup section, and then inside we have one command which is pin mode 7 output. Now we're ready for the loop section. So when the program runs, it's going to run the setup half, and then it's going to start doing the loop section over and over. So I'm going to go ahead and again get rid of the comment, so I just have my code here. And notice that I'm indenting inside the sections, and your code would run if you didn't indent, but it just makes it a lot easier to read. And when your code is super simple, it doesn't really matter, but as your programs get more complicated, it's good to use good form so that it's easier to maintain it. All right, so we want to turn the LED on. To do that, I'm going to use the digital write command. So digital write. And the digital write command needs to know what pin, so let's say pin number 7, and it wants to know what the state would be, which in this case we want to turn the LED on. So we're going to say high, and then semicolon to close the sentence. And then the next line is going to be delay, and we're going to tell it how long to delay. So we're going to delay for 500 milliseconds or half a second. So it'll turn on the pin, It'll delay for half a second, and then it will do the next command, which is going to be a digital write, again to pin 7, but this time we're going to turn it off. So we're going to set it low, and then we need to delay it one more time. So delay 500 milliseconds or half a second, and that is the entire program. Now that our program's done, let's go ahead and save it. So I'm going to do File, Save As, and I'm going to call it Blink 7. And I'll push Save. And now our program is saved. The next thing we want to do is check to see if we have any errors. And I can do that by pushing this little check circle. And it's going to pre-compile my program, which is converting it into language the Arduino can understand. And if everything goes well, you won't get any red on the bottom. Let me break my program so you can see what would happen if we made some mistakes. To start with, let's drop a semicolon. I took that semicolon off. I'm going to hit pre-compile or check. And you can see that it did not like it, and it broke. It says error expected, semicolon before, and if you look up here you can see it's red, and before that it wanted a semicolon. Let's put it back in. I'm going to make another mistake. I'm going to type the wrong command. Let's replace the word delay with the word wait. One of the hints to you that wait is not a valid command, by the way, is that it's colored with black text instead of red text. And that's a hint that, oh, by the way, this isn't going to work. So we pre-compiled it, and again it says, hey, wait is not declared in this scope, which is a weird way of saying I don't know what you're talking about. Let's put it back to delay. And once everything compiles correctly, we can go ahead and plug in our Arduino and see what happens. And then I'm going to push compile, which is this arrow, and that'll compile the program and send it to the Arduino. And if everything happens the way that we expect, shortly after compiling, the Arduino should start blinking the LED, but we will try. So here's my board with the Arduino, and you can see my LED is flashing about every half second. If your board is not working at this point, please contact your instructor and see if you can figure out what's going on or why it's not working. In the next section, we will add to this by communicating with an external sensor, in this case a tilt switch. And what will happen is the LED will turn on when the board is tilted, and it will turn off when the board is horizontal.